In this video, you are going to be reviewing how to solve a linear system by graphing. So remember that a system is two equations or more. So let's say we had, like y equals 2x minus 1 and y equals 4x plus 3. There's two equations. We are going to take a look at three different solutions we might have given two or more equations. And that would be a point. So for example, if we had two lines that would be touching, this point right here with our x and our y at this point would be the solution. Infinite, infinitely many, sometimes, as we've heard before, is exactly the same equations. So it's like one line and then directly over the other line, and you can't even tell that they're two different lines because it's the same exact line, one right over the other. And then no solution is going to be nothing in common. Or parallel lines. They never touch. So that would be lines like that. There are arrows that will let me. And that would be like if the equation was y equals, 1/2 minus 1, y equals, x, 1/2 x plus 3. So we see that we have the same slope there. They're never touching, so there is no solution. Right, so let's go ahead and try this first one. Our slope is 1/2. Our intercept is -3. So let's go ahead and start at -3 down here, going up 1/2, up 1/2, and then graphing our line with a straight edge. Or straight, again, just repeating those dots so that you get as straight as possible because we need to see where they touch. And if we're off just a little bit, then we're not going to be able to see where they would touch. So here is my line, and then this slope, 3/2, and then your b, -1. So -1 right here, and then up 1, 2, 3 over 2, down 3 over 2. Oh, I think I found it. All right, I'm going to circle it so you can kind of see it there, but let's draw my line. And 3 over 2. All right, so that point right there, we need our x and then our y, and that would be at -2, -4. So that is my solution. There's only one solution for number 1, and it's the point where they touch and intersect. All right, if you want to try this one, go ahead and graph it, and then determine if it is a point and what that point is, or infinitely many, or no solution, and then check when you're ready. And you should have gotten parallel lines, so no solution. Oops, wrong way. All right, so on this next one, we can already tell that they are the same line, but since we need to graph it, we're going to go up 2/1, up 2/1, and we don't need to graph the second line because it's exactly the same as the first line. So if you graphed this one, and sometimes it helps if you are doing this on your screen and doing the writing, if you zoom in using your fingers to kind of pinch and then zoom in, it's much easier to kind of draw a straighter line and get things graphed much easier if you zoom in. So maybe try that if you're struggling, but my pen is just, I think the end is going to break off here soon. Promise you I have much prettier handwriting than that, but you know, hopefully you can read that. Infinite solutions. Solutions. I should have my S. All right, so now these last two we need to get into slope-intercept form, and then we can graph them and kind of see what their solution would be. So I'm going to go ahead and subtract my 2x on both sides and then divide everything by -3. So y equals 2/3 x minus 1, and then this one I'm going to subtract 2, so y equals x minus 2. So here's my two equations. Let's go ahead and graph those. So -2 and then up 1 over 1, up 1 over 1. When we just have the x, we have a slope of 1 over 1, right? So that one. And then -1. And then up 2 over 3. Oh, found where they meet. So let's go ahead and draw that other line though. So they are meeting there at 3, 1. All right, go ahead and try this one on your own. Change it in slope-intercept form and then graph them and then see what your solution would be. Hopefully you got -3, -5. Now this one was a little tricky because it had a half. You will not have one like this, but if you tried it and you got it right, pat yourself on the back. If you struggled a little bit, I totally understand. Again, you will not have to graph ones that would have a fraction and kind of go from there. So good work.